Stopped on the congruent supplements theorem, which told us if both 1 and 2 were both supplemental, or sorry, 1 and 3 were both supplemental to 2, then they're equal. Or if, I don't know where the 1 went, but if 1 and 2 add up to 180, and 3 and 4 add up to 180, and 2 and 3 are the same, then that means 1 and 4 are the same. Okay. The next one is we have the congruent complements theorem. So it's basically the same idea. Oh, let me just go back again. Supplements is 180 degrees is what they add up to. Complements add up to 90 degrees. So this is the same idea. If I have angle 1 and angle 2 add up to 90, and then I have some angle 3, and angle 3 and angle 2 add up to 90. Then that means angle 1 and angle 3 are the same. And then we have if angle 2 and angle 3 are the same, and angle 1 and angle 2 add up to 90, and angle 3 and angle 4 add up to 90. 2 and 3 were the same. That means that angle 1 is the same as angle 4. Okay, so we have the vertical angles theorem. Now, some books call this a theorem. Some books call this a definition. So when you guys are writing proofs, if you use vertical angles in your proof for whatever reason, and you say, you know, angle 1 is congruent to angle 2, you can either write vertical angles theorem or you can write definition vertical angles. I don't care which you use because, like I said, it depends on the book, whether the book publisher or writer considers it a theorem or a definition. So you just write vertical angles and I know what you mean. Okay, so vertical angles, again, are formed when two lines intersect, and you get 4 angles. And the vertical angles are across from each other, so angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. And this is not part of the theorem, but angle 1 and angle 2 are 180. Angle 2 and angle 3 are 180, not 1800. Angle 3 and angle 4 are 180, and then angle 4 and angle 1 are 180. And that's where we get that the angles are congruent, because 1 and 2 add up to 180, 1 and 4 add up to 180. That means 2 and 4 are the same. So the vertical angles theorem came from the complementary or supplementally congruent theorem that we just did yesterday. So that's kind of where it comes from. So that's why some books consider it a theorem, some books consider it a definition, because it's really kind of a corollary. It came from the other thing. Does that make sense? Okay. Right angle theorems. Okay. So I'm going to write them down really quickly, draw the pictures, and then talk about them. Okay, so the first theorem is that perpendicular lines intersect and form 4 right angles. Well, this is kind of one of those situations where the definition of perpendicular is that you are at a right angle. So it makes sense that they would form 4 right angles. So angle 1, angle 2, angle 3, and angle 4 are all right angles. Okay. All right angles are congruent. Well, this also makes sense because a right angle is 90 degrees, and if you're 90 degrees, you're congruent to everything else that's 90 degrees. So this is one of those ones that, so angle 1 would be congruent to angle 2, and angle 3, and angle 4. And then perpendicular lines intersect to form congruent adjacent angles. These two angles are next to each other. They're adjacent. They share a side. They're congruent. And 2 and 4, adjacent and congruent, and 3 and 4, and 1 and 3. So angle 1 is congruent to angle 2. Angle 2 is congruent to angle 4. Angle 4 is congruent to angle 3, and angle 3 is congruent to angle 1. The adjacents. From these, we get the next two. If two angles are congruent and supplementary, so angle 1 is congruent to angle 2, and the measure of angle 1 and the measure of angle 2 is equal to 180, that means that they're both 90 degrees. Which again, if they're making a straight line, or they're making 180 degrees, but they're the same size, you divide it by 2, it's 90. There's nothing else that could work. And then if two congruent angles form a linear pair, then they're right angles, which again, this makes sense because a linear pair is 180 degrees, and so angle 3 would be congruent to angle 4. Oops, 3. And they'd add up to 180, and then that would mean that they were both 90 degrees. And coplanar, because they're kind of similar. Okay, collinear occurs with points, and that's when two or more points are on the same line. Co is the prefix that means together. So like if you think about cohabitate is when you live together with somebody. Cooperate is when you operate together with someone. So co means together. So these are two or more points that are on the same line are collinear. And then coplanar is two or more points or lines. Actually, it could be points, lines, rays. You can have angles that are on a plane, anything that's kind of flat, that are on the same plane. Okay, so if we have some line, this dot and this dot would be collinear. This dot over here would not. And if we have a plane, it's a terrible plane. I cheated. Okay, like this line and this line would be coplanar because they're on the same plane together, but this line over here would not be because it's out in space somewhere. Okay. From there, we'll go to concave versus convex. And this has to do with your polygons. You can have a concave polygon or a convex polygon. And you remember the concave polygons were all really open. Things like this. Convex, sort of dented in. And the way you can tell if it's concave or not is if you connect the inside lines. Well, actually, we don't want to do that. If you extend out the sides, none of the lines go inside if it's concave. And if it's convex and you extend the lines, they'll go inside. So if even one line, if you extend it, crosses into the shape, it's concave. But I kind of just like to think of it, or sorry, convex. I just kind of like to think of it as they're kind of dented in. If you know they have a side that looks like it got hit, and it's dented in, then it's convex. This is a polygon with n number of sides. And so this is for polygons that you don't know the specific name for them. Like if you had a 22-sided polygon, you guys don't know the name for 22 sides, so you would call it a 22-gon. Okay. You have triangle is the smallest polygon you can have, and that's got 3 sides. And then you have a quadrilateral with 4. Pentagon has 5. Hexagon has 6. Heptagon has 7. Octagon has 8. Nonagon 9. Decagon 10. Hendecagon dodecagon is 12, and then you have never can remember how to spell that. An isosagon has 20. Anything else? Just like if it's got 13, call it a 13-gon. If it's got 95, call it a 95-gon. Okay? Okay, so a polyhedron is a 3-dimensional figure made up of polygons. Okay, and within that, you have total branches of math devoted to the study of these things. But the sides are made up of polygons, so they're flat. The sides are all flat. So not a sphere, not a cylinder, not a cone. Okay, cubes, boxes, rectangles, rectangular solids, pyramids, dodecagons, which is kind of like a soccer ball if it wasn't round, but you flattened all the little shapes on the side. These are all polygons or polyhedrons. So they're 3D figures made up of polygons. All the sides are flat. Okay. Now within the polyhedron, we have the other words that are that. We have prisms, and we have pyramids, and then we have other things. Now a prism occurs when you have like a top and bottom. These are known as the bases, are congruent polygons. And the sides are all quadrilaterals. So if you have a box, a box is a rectangular prism. Because the top and the bottom are congruent rectangles, and then all the sides are rectangles. if you have a pentagon, and then it goes down, and then there's another pentagon on the bottom. I can't draw these very well, but you get kind of the idea. It's like a pentagon and a pentagon on the top and bottom, and then all the sides are rectangles. Then that's called a pentagonal prism. And the prisms are named by the shape of their bases. Well, it's the same kind of idea with a pyramid, except with a pyramid, it has a base, is a polygon, and the sides are all triangles that meet at a common vertice. Okay, and when you think of pyramid, usually the first thing that pops into your head is Egypt, right? Pyramids, Egypt. I'm not very good at drawing these either. I'll just pretend there's a line behind there. And that would be a square pyramid. And we can have like pentagonal pyramids, etc. And they're named also by the shape of their base. So whatever that shape is that's on the bottom of the pyramid, or on the top if you have it flipped over, is the name of the pyramid, and then all the sides are going to be triangles that meet at a point. So kind of the difference between a pyramid and a prism is that basically the only difference is you have two bases on a prism that match. You have one base in a pyramid, and then the prism has rectangles around the sides and the pyramid has triangles. Yeah. Yeah. Okay, so to bisect means to cut in half. So a bisector cuts things in half. And so we have the segment bisector. It cuts a line segment in half. Okay, and this can be a point, a segment, a ray, or a line. Basically anything that if I have some line segment AB, this thing will come through and this is the bisector, and it'll make these two sides equal. And a bisector hits a line segment at the midpoint. And since we're on the topic, we'll just talk about an angle bisector too. And it cuts an angle in half. Now this can't be a point, because a point can't cut an angle in half. But it can be a segment, a line, or a ray. And so if I have some angle, the bisector will come in like that, and then this angle gets cut in half so the two sides are equal. Price of grapes versus pounds. The rate of change is the cost per pound, because the cost of the grapes goes up based on the number of pounds you buy. All right, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And then point slope form is y minus y1 is equal to m times x minus x1, where x1, y1 is a point on the line. And m is still the slope. Okay. Transversal occurs when I have two lines. The transversal is a line that intersects both lines. Well, it intersects two or more lines. So this line here would be the transversal because it's intersecting the other two lines. And the transversal is what creates all of these. Does anybody want me to go over those? Yeah? Okay, hold on one sec. Okay, alternate exterior angles are on opposite sides of the transversal on the outside of the lines that it's intersecting. So these are alternate exterior, or these are alternate exterior. So this is one pair of alternate exterior angles, this is the other pair. Alternate interior angles are in between the lines on the opposite sides of the transversal. So here and here. Consecutive interior angles are on the same side of the transversal. So these are consecutive or these are consecutive. And then you have corresponding angles. Now corresponding angles are in the same position. So this one and this one, they're in the same position. This one and this one. This one and this one. And this one and this one. So if you make this like a 4 square, and this is a 4 square, they're in the same square. Does that make sense? Skew lines are lines that are not parallel, but they don't intersect. So if these two pins, these are parallel, right? But if I turn this one this way and I bring this one up here like that, they're not parallel because they're not running the same direction anymore, but they're also not intersecting. So this occurs when lines are not in the same plane. Because if they were in the same plane, they'd intersect. Okay. So, in different planes. Again, so the first one is the corresponding angles postulate. And the corresponding angles postulate tells us that if two parallel lines, now they have to be parallel, are cut by a transversal, then the corresponding angles are congruent. Okay, so if I have two parallel lines and I bring in a transversal, and I number all the angles, angle 1 is going to be congruent to angle 5 because they're in the same position. Angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. 2, 6, 3, 7, and 4 and 8. Now we have the converse of this. So I'm just going to do this at the same time, so because they go together, but they're backwards. Okay, so the converse says that if two lines are cut by a transversal, and the corresponding angles are congruent, then the lines are parallel. So we've got can't spell parallel. So we've got the one theorem that says if you have two parallel lines and you make the transversal, then the angles are congruent. And then to go backwards, if you have two just random lines in space and they have those congruent angles, then that means the lines are parallel. So they're just two sides of the same coin. One has the theorem and the converse. And so we have if two parallel lines are cut by a transversal, then your alternate interior angles are going to be congruent. So angle 1 will be congruent to angle 2, and angle 3 will be congruent to angle 4. And then the converse says if you have just two random lines and they're cut by a transversal, and then the alternate interior angles are congruent, then that makes the lines parallel. So the parallel lines makes the angles congruent. The congruent angles makes the lines parallel. Goes both directions.